Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the NRO-L-61 mission for the National Reconnaissance Office. Good morning and welcome to Cape Canaveral Air Force Station here in Florida. I'm Matt Donovan, the Propulsion Engineering Manager for ULA's Human and Commercial Systems. I'm here in the mission control at the Atlas Space Flight Operations Center. At this point in time, the launch team is not working any issues and we're proceeding towards liftoff at 8:37 a.m. Eastern Time. A few seconds from now, the count will enter a planned 15-minute hold. There are 2 planned holds in our nearly 7-hour launch count. The planned holds give our team additional time to resolve any issues prior to entering the terminal count at T-minus 4 minutes. At the request of our customer, today's live coverage will conclude following payload fairing jettison, which is scheduled to take place about 4.5 minutes after liftoff. Todd McNamara, the 45th Space Wing Weather Officer, just provided us with an updated weather briefing, and everything looks good for today's launch. The probability of violating launch constraints is 0%. The ground winds are 7 to 11 knots out of the southwest, and the temperature is 84 degrees Fahrenheit. With that favorable forecast, we are proceeding towards a planned T0 at 8:37 a.m. Eastern Time. After liftoff, the Atlas V will be flying in a southeasterly trajectory away from Cape Canaveral. Let's take a quick look at what we'll be seeing later today.
The following profile details the important events of this mission using approximate times.
T-minus 5, 4, 3, 2, we have RD-180 ignition and liftoff of the United Launch Alliance Atlas V rocket.
The Atlas RD-180 main engine and 2 solid rocket boosters ignite to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic loads. The Atlas V reaches Mach 1, the speed of sound, at 47 seconds. At 52 seconds, the vehicle experiences maximum dynamic pressure. The 2 solid rocket boosters, or SRBs, are jettisoned at 2 minutes 9 seconds into the mission. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,672 pounds per second, traveling at approximately 12,550 miles per hour, and located 72 miles in altitude and 238 miles downrange. Booster engine cutoff occurs 4 minutes 10 seconds after liftoff. 6 seconds later, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. At 4 minutes 34 seconds, the payload fairing is jettisoned.
NRO-L-61 is the 64th Atlas V mission and the 109th ULA flight. The NRO-L-61 mission uses the Atlas V 421 configuration. Here's more about the rocket and launch processing, including my visit to some of our launch facilities here at Cape Canaveral. Produced in Decatur, Alabama and Harlingen, Texas, the Atlas V 421 includes a Common Core booster powered by an RD-180 engine with 2 Aerojet Rocketdyne solid rocket boosters and a Centaur second stage powered by an Aerojet Rocketdyne RL-10 C1 engine. The satellite is protected during ascent by a 4-meter diameter payload fairing. Initial launch processing of the Centaur second stage takes place here in the Atlas Spaceflight Operations Center.
Early steps in the process include checkout of the propulsion and avionics system, including turning on the vehicle with power to check out wiring as well as instrumentation.
With initial testing complete, the Centaur and several structural elements are integrated at the Delta Operations Center, or DOC. This type of integration was previously done at the launch pad. By moving it to the dock, which provides protection from the weather and reduces the number of lifting operations, we've reduced processing time by as much as a week. Once assembled, the Centaur is transported to the Vertical Integration Facility, or VIF, at Space Launch Complex 41, where final launch processing takes place. On July 19th, the NRO-L-61 satellite, encapsulated inside the payload fairing, was transported to the VIF and mated to the Centaur. The launch countdown begins with moving the rocket from the VIF to the pad, which is a quarter-mile trip that takes about 20 minutes to complete. Weighing in at about 2 million pounds, the Mobile Launch Platform, or MLP, supports the vehicle and contains air conditioning, electrical, and commodities, while the undercarriages bear the weight of the MLP and the rocket. 2 rail cars lead the move, with the payload van providing communication to the payload, while the ground van houses the ground support for the launch vehicle. At the rear of the convoy, the Portable Environmental Control System provides air conditioning to the rocket and payload. Finally, trackmobiles provide the power to move the 3.5 million pound convoy.
The Atlas V rocket stands 195 feet tall, or almost 20 stories, and weighs about 1 million pounds fully fueled. The RD-180 engine and 2 solid rocket boosters produce approximately 1.5 million pounds of thrust to lift the vehicle away from the pad and on its way to orbit.
This is Atlas Mission Control at T-minus 4 minutes and holding. Today's launch is for the National Reconnaissance Office. The NRO is a joint organization engaged in the research and development, acquisition, launch, and operation of innovative overhead reconnaissance systems necessary to meet the needs of the intelligence community and the Department of Defense. The NRO is recognized for its transformational intelligence collection systems that are used to develop highly accurate military targeting data, support international peacekeeping and humanitarian relief operations, and to assess the impact of natural disasters. The NRO provided artwork for today's mission, which is visible on the payload fairing. The mission patch features Spike, a lizard, riding the Atlas V to space.
T-minus 12 minutes.
Today's flight is dedicated in memory of ULA employees Paul Fusick and Robin Melendez. Paul's career spanned more than 30 years, beginning with the Titan program and more recently with the Atlas V program, where he provided critical electrical system support. Paul's education and expertise in electrical engineering made him a vital asset, supporting every Atlas V launch during his time at ULA. Paul was known for his attention to detail, his willingness to teach young engineers, and his incredible sense of humor and kindness. He was very well respected and always willing to help anyone in need. Paul was an avid guitar collector and guitarist who will be greatly missed by his family and friends. The flight is also dedicated to the memory of our friend and teammate Robin Melendez. A Vietnam-era veteran, Robin was a metallurgical engineer and dedicated space enthusiast. With a passion for all things space, he worked on multiple programs in the aerospace and defense field. Robin possessed a wealth of knowledge, and he was always willing to share that with those who had the pleasure of working with him. His loss leaves a void that will not soon be filled, and he will be greatly missed by all of his family, friends, and colleagues. It's an exciting and busy time for the ULA team here at Florida's Space Coast. Yesterday, as our Atlas V rocket stood ready to launch NRO-L-61 from Space Launch Complex 41, Preparation for next month's Delta IV launch took place over at Space Launch Complex 37, ULA's other facility here at Cape Canaveral. As you can see, the mobile service tower was rolled back 300 feet, revealing the Delta IV rocket. If it looks a little odd, it's because the payload has yet to be mated to the rocket. Yesterday's test was a chance to verify systems prior to payload mate and other final launch preparations.
SC, verify spacecraft is transferring to internal power.
Roger.
OSM, place SRB SNA switch in the
We recently received a video question from Facebook follower Catherine Grace in Satellite Beach, Florida. Let's take a look at the video.
My name is Mary from Satellite Beach, Florida, and I was wondering, how long does it take to build an Atlas V rocket? My name is Drew, and how much people does it take to build a rocket?
So thank you, Catherine, for submitting that. Those are a couple of really good questions. We'll start off with how long does it take. I'll tell you, it all depends on the complexity of the rocket that we're building. But for most of our configurations, it takes less than a year to build. And actually, over the last couple years, we've cut the time in half that it takes to build and then process here at the launch site for our rockets. As far as how many people it takes, from a ULA perspective, it takes thousands of people to make happen what you see today. Some of those people are working on the actual production of the vehicle, but we also have folks that track the costs, organize where the rocket needs to be, when it needs to be there, and also working on future rockets that we're developing. So although it may only be hundreds of people that put their hands on the vehicle, it takes a team of thousands to make these missions a reality. And for me, I have the opportunity to work on missions that we have coming up, modifying our Atlas V and Delta IV to be able to put astronauts in a CST-100 Starliner capsule and send them to the International Space Station, as well as be able to launch Orion on its trip around the moon. So thank you very much for that question. We remain in the planned 15-minute built-in hold as final preparations for launch continue. In a few moments, launch conductor Scott Barney will poll the team for the final go to pick up the countdown. 27 engineers and managers are polled for system status and readiness to proceed with the launch. This is the final status check for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, pad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion. Go. Hydraulic. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems, propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. HASGAS. Go. Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS. Go. Flight control.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS. Go. Red line monitor.
Go.
Quality.
Go.
Safety manager.
Go.
ULA safety officer.
Go.
BSE.
Go.
Anomaly chief.
AC is go.
Range coordinator.
Clear to proceed.
Launch director.
MD, the launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. T0 is planned for 12:37 Zulu. Set count to start at 12:33 Zulu.
Roger. T0 is set for 12:37 Zulu. Count will start at 12:33 Zulu.
Polling is complete and the team has given the go for launch. From T-minus 4 minutes until T0, you'll hear Scott Barney and his team ticking through the final steps in the countdown procedure. You'll hear the team confirm securing of Atlas liquid oxygen topping, followed by the call to transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures. A final status check of Atlas, Centaur, and NRO-L-61 readiness is conducted at T-minus 25 seconds. Seconds before liftoff, the RD-180 engine ignites and performs a health check, followed by ignition of the 2 solid rocket boosters to lift the vehicle off the pad. After liftoff, you'll hear the voice of Marty Malinowski providing flight commentary.
On my mark, the time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
3:55.
Ground pyros enabled.
The countdown clock has resumed, and we are go for launch at 8:37 a.m. Eastern Time.
Three minutes. Securing LO2 topping.
Atlas tanks to flight pressure.
250. FPS internal. $159.
Vehicle internal.
155.
On sequence start.
150.
Securing Centaur LH2. Securing Centaur locks.
140.
Launch enabled.
137. FPS armed.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
OCU's armed.
SCS count started.
110.
Vent valves locked.
T-minus 1 minute.
Report range status.
Range green.
$40.
Stable at step 3.
$25.
Status check. Go Atlas. Go Centaur. Go NROL-61.
20. 15.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the NRO-L-61 mission for the National Reconnaissance Office.
Boost PU has gone to closed loop control. RD-180 chamber pressures are good at this point. SRB chamber pressures are rolling off. Pitch program is complete. Boosters throttled down, right on schedule. Roll program is complete at this point. Mach 1. Boosters throttle up, right on schedule. Engine response looks good. SRB chamber pressures have plateaued. Now passing through maximum dynamic pressure. Signatures look good. Current altitude is 10 miles. Downrange distance is 4.8 miles. Current velocity is 1,985 miles per hour. Coming up on SRB burnout. And we have SRB burnout. Signatures look good. Booster has throttled back to full thrust. RD-180 continues to perform well. And at this point, the booster is now 50% of its liftoff weight. Coming up on SRB jettison. And we have indication of jettison of 2 solids. Signatures look good. Closed loop steering has been enabled. Small body rates at this point in time. And booster is throttled back, right on schedule. Again, RD-180 signatures look very good. And we have indication of the RCS pyro valve firing. That system is now pressurizing the flight level. Signatures look good. Current altitude is 42 miles, downrange distance 86 miles, current velocity 6,137 miles per hour. RD-180 continues to perform well. Pump speeds look good. Booster is now 25% of its liftoff weight. Booster engine continues to perform well. Currently flying at 5 Gs. It's throttling to maintain that. Boost phase cooldown is underway. And we have begun to throttle to 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good. And we have indication of stage separation. We have LOX and fuel pre-start underway. GN2 purge firing of the RCS. And we have ignition and full thrust on the RL-10. And we have indication of payload fairing jettison. Looks like a clean separation.
This is Atlas Mission Control at T plus 4 minutes, 53 seconds. An Atlas V rocket carrying NRO-61 for the National Reconnaissance Office lifted off at 8:37 a.m. Eastern Time, and all systems continue to operate as expected. At our customer's request, we will now be concluding our live broadcast coverage. Before we sign off, I'd like to thank Marty Malinowski for his support of this morning's broadcast. To learn more about ULA or the Atlas V, you can visit www.ulalaunch.com or join the conversation on Facebook or Twitter with the hashtag NROL-61. We'll leave you now with one more look at this morning's liftoff. I'm Matt Donovan, and on behalf of the entire launch team, thank you for joining us and have a great day. 8, 7, 6, 5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the NRO-L61 mission for the National Reconnaissance Office.
Boost PO's gone to closed loop control.